we've seen is that AI has grown and grown and grown. And now all of a sudden, Nvidia has found themselves in a very, very perfect position to capitalize on this gold rush towards artificial intelligence. We have these standards and that we're first to this technology on this scale, and that China or Russia was not first and attacked, our country with content like this. And, we could do this to other countries. This is a weapon. This is one of the most powerful things humans have ever created.
So being able to understand and have the data from social media of like, here's what inflames certain people, but being able to make the perfect video. You're not having to rely on traditional media production methods to do it. You have AI being able to generate it and being able to deliver it, and like building, like that is the equivalent of essentially building a nuclear weapon from a software perspective.
So I think just to frame it for people to really understand what's going on here, we are rebuilding the internet right now.
Welcome back to the Middle Tech Podcast. You've got Logan Jones here, joined by Evan Knowles. Today's episode is going to be a little bit different. It's going to be more like some of the episodes we did last season, where we're covering some relevant news stories, this time in particular in the artificial intelligence space. So as you know, there's been all sorts of news going on within the AI space here lately. So we're going to cover a few different stories that have broken over the past few months. So those stories are going to be the new OpenAI model, Sora, the text-to-video model, Nvidia's new valuation being, I think, the fourth most valuable company in the world right now, and then Google's Gemini 1.5 model. So we're going to dive into those stories. Before we do, we just want to get a quick word from our sponsors. Before highlighting our sponsors, we'd just like to state that the views and content shared on this platform do not necessarily reflect those of our show sponsors. Middle Tech is presented by KY Innovation, the Kentucky Cabinet for Economic Development's Office of Entrepreneurship. KY Innovation exists to support and develop Kentucky's startup ecosystem, and we are proud to be supported by an organization whose mission aligns so closely with ours. If you're a founder building in Kentucky, you need to check out the resources that KY Innovation has to offer. You can find more information by clicking the link in our show notes or going to kyinnovation.com.
Middle Tech is sponsored by Bolt Marketing. Take your website to the next level with a website that's built to work. At Bolt Marketing, they're revolutionizing websites for small businesses that are affordable, customizable, and hassle-free. Whether you have a construction company, a boutique clothing store, or you own a hot yoga studio, they have options for you. Click the link in our show notes to explore their marketing options that can transform your marketing and grow your business. And as a personal note, Bolt Marketing built our website, and they were awesome to work with throughout the entire process. We highly recommend working with them.
All right, Evan, let's dive into this. How's it going?
Yeah.
How's your weekend been?
Good, man. It's been a great weekend. A lot of fun. I went out to dinner last night with some friends, and actually worked most of the day Saturday, but worked on some fun stuff. So it's been good.
Nice. Yeah, we got to see a good Cats win against Auburn. So I feel like the fan base is going to start rallying behind Cal, hopefully a little bit more. He really needed that win just to win back the support of the fans. So that was exciting.
Yeah, we won that without a couple of our best players.
I know.
I feel like we didn't play Big Z or Bradshaw, and then Mitchell was out. So it was a good win on the road.
Very encouraging going into March. So as a Cats fan, I'm pretty pumped about that. But cool. So like I mentioned at the intro of the episode, we wanted to take an episode to go over some of the recent news in the artificial intelligence space. Evan, as an AI founder, it's something you're following very closely. And then just because I'm interested in the space and also your roommate, I follow it very closely as well. We have a lot of conversations back and forth about it at the condo. So we felt it was, there's been enough gone on here lately that it would be worth dedicating an episode to talk about what's going on in the space. So as I mentioned, we're going to be going over three primary topics. First of which is OpenAI's new model, Sora, the text-to-video model. We're also going to be talking about Nvidia's valuation and their role in all of this. And then we're going to be talking about Google's new Gemini 1.5 model. So let's kick it off by talking about Sora. Sora is, by the time this episode will come out, will be about 2-ish weeks old, 2.5 weeks old, week and a half old, something like that. So as of this recording, it came out Thursday of this week and absolutely set the internet on fire with what they were able to produce. So let's just start this, Evan. Tell us a little bit about your reaction, and then let's dive into what this model is actually doing, and then we'll dive into how it's doing it.
Yeah. When I first saw it, I mean, I was, of course, just kind of amazed at what they had created and done kind of in secret. So nobody really kind of knew this was coming. They didn't really have any awareness that they were working hard, on this problem of generating videos from text, which is a very hard problem to solve that requires, a lot of moving pieces and a lot of data. And so when that released, you kind of saw it actually overshadow one of the other stories we'll talk about, which is the Gemini update from Google. I think OpenAI released it maybe the same day or the next day after they released that model, probably on purpose to overshadow it, and they did exactly that. And so it's a really big deal for these AI companies to create text to video because there's so many interesting applications, especially on the media side of things. And so, yeah, I wasn't surprised by how much attention it got. I was surprised on how advanced it is, given this is their first release. And so it's pretty exciting, and we'll see what applications there are. They're being very careful about who has early access to it, so we can talk a bit about that as well and how they're keeping safety in mind. But yeah, I was more so surprised that they were doing this in secret and released this kind of out of the blue.
Yeah, it makes you think about what else they might be working on at the same time that we're just not aware of yet. Obviously, my reaction was the same. No surprise that it's gone as viral as it has, just because it's a video generation model. So it's obviously very easy to just see plainly what this thing is able to do and be just genuinely impressed with the output that you're getting from a simple text prompt. Some of the commentary that I saw on Twitter about it, and also this was one of the long form conversations I listened to about it on the All In podcast, are talking a lot about how this was able to be done. And I think it's worth just diving into the weeds just a little bit here because it's very relevant to how the AI space is functioning at kind of the core level. So the first part of this that I wanted to kind of dive into in terms of how the model is doing what it's doing revolves around some speculation on how it's actually rendering some of the physical space that you're seeing in the video. So if you've not gone and checked out some of the videos that it's produced, you can go on Twitter, go to Sam Altman's account, or just if you just scroll, I'm sure you're going to start seeing examples. Most of the footage that I'm seeing is indistinguishable from real video footage. The one video that I'm seeing in particular that I want to refer to here, it looks like a drone shot following some sort of car going along a dirt road. Looking at that, it's hard to distinguish from reality. And so on the All In podcast, one of the topics that was discussed that Friedberg brought up is he was saying that in order for this to actually be possible, OpenAI has likely, and this is again speculation, but they have likely gone and used an Unreal Engine or some sort of physics engine like that to go and generate all of the synthetic data, basically all of these different models of worlds and of 3D spaces, and then use that synthetic data to then train a model on how to produce images like that. So Evan, I want to kick it over to you on that, because I think this is one of the most interesting pieces to talk about here technically. I know it does get into the weeds a little bit, but this starts to revolve around the conversation of what you and I were talking about earlier today with taking human determinism, I guess, out of software development, which I think is a very interesting concept. So just talk about kind of what's going on when I say that a physics engine is rendering that, and then they're using that to train a model, and maybe one of the alternate theories that you have as well that we were discussing earlier.
Yeah, so popular like physics engines, Epic Games has one called Unreal Engine, and then there are others that create video games. And so video games are, physical representations of virtual representations of physical space. And so they have all this documentation, all of these rules and logic around, how physics works, because they have physics engines. And so the speculation and kind of the really questioning around this release was, where did they get the data to generate so realistic videos? And in order to have a realistic video, the video has to represent real world physics so that it looks real. And so a lot of the question is where they got this data. And so people are speculating, like you said, that they partnered with an existing physics engine, and likely what might be happening is users can input a prompt just like they would with DALL-E or a large language model like ChatGPT. And what happens is on the back end, that prompt is put through a large language model that interacts with one of these physics engines that has really good documentation for the large language model to autonomously create a representation of what the user basically input, and use some kind of diffusion model, which is another type of model, to create that video. And so that is kind of what people are speculating, is that, again, they have some kind of partner or have created their own physics engine on the back end that is working in coordination with a large language model to basically digest the prompt and then spit out these videos that are highly realistic. So that would be a really interesting bit of information that I think we all would love to know. I would guess that they partnered. I would say that their core competency is likely not a physics engine. They've done a great job with large language models and obviously diffusion with DALL-E. Maybe they have in the background been working on a physics engine, but I wouldn't be surprised if they partnered with somebody just like they partner with Nvidia for their hardware or other aspects of their tech stack. So I thought that was a really interesting conversation as well, and I'd be curious to know where they got that data from, because traditionally the companies that have kind of real world physics engine and knowledge around that would be the autonomous car companies, so Google, Tesla, and others. Nvidia has been working on a physics engine, and then these video game companies. So I would be curious where they got that data. So yeah, to your point, I think that is one of the most important conversations related to Sora, is kind of that piece. In order to create realistic representations of the world, they've got to have that data. One of the things that I noticed about the physics engine was that when it breaks, I'm not sure. One of the most interesting things about this was I'm not sure I've seen physics break like that. So what I mean by that is, if you were to pull up a video here, let's maybe, while I'm talking about this, can we share our screen here? I can share my screen, right?
Yep.
So if I go to Sora on OpenAI's website, one of the most interesting things about this whole launch was there really hasn't been a reason for us to see real world physics break in a video, because in order for physics to break, it has to be fake, of course, but it would have to be generated in a photorealistic manner. And there's really not an incentive in the world right now to create a break in physics for really anything other than maybe some really weird movies. And so to see an AI generate like a glitch in physics is really interesting to watch. So if I share my screen here, let me pull this up. This is what I'm talking about. So this video is really trippy to watch, because again, there's really no incentive in any real world application to mess up physics. You can't see it in real life, and you don't see any incentives in the media world to break up physics, really, again, unless it's just a really trippy movie. And even those, it's hard for them to mess up physics. And so to see something like this and see it so realistic is wild. And so I just thought that was an interesting part of this release, was seeing it break physics, and there'd be no downsides.
Well, the interesting part about it breaking physics, as you're saying there, is that it's also smooth. Like, there's no like real hard glitches where it's like, okay, obviously this is, like you could pass that as a magic trick. If you saw it in real life, like I would imagine it looking like that if that were to exist in real life, if that makes sense. So I feel like this could give rise to all sorts of really crazy sort of video content as well. I do want to back up for just a second. You mentioned that you think that they're probably partnering with a physics engine of some sort in order to render these things. Within the All In podcast, one of the more interesting things that I thought came up, and again, this is not confirmed, so I still want to discuss it though, is that Friedberg was saying, okay, if they're using a physics engine, and then rather than, if a prompt comes in, basically making an API call to the physics engine to generate some sort of world that is related to the prompt, and then kicking it back, that seems like it would take a lot of time and compute power. I'm not certain though, but rather they generate a bunch of synthetic data. And the reason I think that's interesting is because if they're generating synthetic training data to train this model, then they're essentially letting the model determine how to render physics. They're allowing the model to learn that itself and potentially do that with less compute than something like an Unreal Engine. So do you think that it's more likely that that's happening, or that the scenario you discussed where the prompt comes in and they're almost making like an API call to an Unreal Engine and then passing that back to the model to use a diffusion sort of process to give the video? Which do you think is the more likely path, if either of them?
I mean, either way, on both paths, they have to find some body of data to train the model on to understand physics. So either way, they either had to partner with somebody that already had all of that really well built out because they're already building a physics engine, or they had to train it on existing rules and logic around physics that might, be in internet text. So either way, I do think the model is generating, these representations of physics. It's just the question isn't whether that's happening. I think that is happening. The question is where they get that massive amount of physics data.
Yeah.
And again, the only people in the world that have that data are the autonomous car companies, and the ones that have purposely been developing some kind of physics related data like gaming engines, or I know Nvidia has been working on that for a while. So again, it's not a matter of if they're doing that. I think that if they're not doing that now, they will be letting the model kind of generate how physics works using an existing body of data, but just rather where is that data coming from? Because it's very, very complex data to train a model on. There are just so many rules and logic around real world physical space, and the variations of that are almost infinite.
Yeah.
Right.
Yeah. I know that's pretty in the weeds, so bear with us. We just wanted to really dive deep into what some of the discussion has been around this model since its release. The more fun part of the discussion, though, that I put some stuff out on my story. I know you and I have talked a little bit about it as well. And this has really been a discussion that has kind of gone on since AI became mainstream and since large language models really became a mainstream term. And that is what's going to be the consequence of being able to generate video that is indistinguishable from real video using a text to video model like this. And so here is, the part of the discussion where I want to discuss, problems like being able to trust videos that you see online. I know you put some notes in there about how OpenAI is planning to address that, but also just what the future could look like. Because I think it's pretty crazy when you're talking about a model being able to synthesize a physical environment virtually. That gives rise to, essentially synthesizing your own content based off of prompts, based off of, if you wanted to design an entire new world like that, gives rise to pure creativity and pure externalized imagination, which I think is very fun to talk about. But yeah, before we talk about that, let's dive into how this could impact, media production, Hollywood here in the near term. So based off what you're seeing so far and your understanding of this, maybe start off with how far off a significant change to those industries is going to be, and what you think that change is going to be.
Yeah, I mean, initially it's going to be a toy, just like DALL-E has been. And then, people will start creating, I think, what's the word for content that is just kind of filler? Content?
B-roll.
B-roll's done. Just like with, Getty Images and some of these other places where you go get stock photos. So B-roll is going to be done. So I would say it's going to start as a toy, and then little short clips. So right now it's only a minute long that can be created. So short clips will be kind of the lowest hanging fruit. So again, B-roll. And then it's hard to imagine it actually replacing humans for like long form film. I think that it's going to be capable of that, but it's going to be really interesting to see how far off that is. And, if people will want that. I think people will be okay with that. If they can't distinguish the difference, I don't know why that matters, but it's just going to be a societal question we're going to ask ourselves. Like, do we want to see art generated by humans, or does it matter if it's generated by a computer? So I don't think we're far off from that world existing, but I just think the progression of it's going to be, again, a toy, B-roll, and then you'll start to see it bleed into longer form content. And then where it goes from there, I don't know. That's also going to blend with virtual reality as well. So
Yeah.
I would say my timeline on all this would be in 3 to 5 years, Hollywood will be disrupted from film. And then in the short, 1 to 2 years, B-roll and, a lot of these toys will be created for more like social media content generation.
Yeah. I think one of the interesting aspects I've seen of Sora being used as a tool that I could see being used pretty heavily in Hollywood and video production and media production. Did you see the example where it was the red car driving down some like mountain road, and they fed that into the model, and then they were able to say, now make this underwater, make this a winter road, make this claymation. And it essentially like kept the scaffolding, let's say, of the video of like the same motions and going through the curves of the road and everything, but it made it in a new style. And I could see that being a very, very useful tool when it comes to like you shot a piece of content, but now you want to change some aspect of it using this model to do so would be a very cool use case for it.
Yeah, I think a really cool use case that stood out to me when I was looking at their example clips is education. There's a clip on there of historical footage of California during the gold rush. I mean, why as a student would you ever want to go look at a picture of the gold rush or look at it in a book anymore?
Yeah.
If you can generate what it actually looked like, to be in California at that time, which this video, let me just share my screen again. This video is amazing. It just looks so realistic. And so education, is going to change completely.
100%.
And I think that's one of the probably more exciting applications, because there's people all over the world that want to learn more about other places and do it on demand, and maybe in a way that they want to incorporate their own imagination, and this is how they do it. So I think this is just so exciting for education, is one of my first favorite places to think about this being used.
Yeah. One of the other potential applications I could see this one being fairly far off, and I'm not sure technically how possible it really is, but I made the joke on my story when I was posting about this that I'm looking forward to being able to generate a new season of The Office, let's say, or a new episode of The Office, where you'd be able to essentially take existing IP, such as the TV show The Office, and be able to generate an entire new episode using the same characters and the same IP that the episode was built on, or that the series was built on. I'm really not sure technically how hard that's going to be to do, because you're going to also like that. It's not just going to be completely AI generated, but I feel like this AI model could play a big part in getting you there. I don't know how realistic do you think that is, that we can get to a point where you can take existing characters, existing IP, and then use a model like this to synthesize an entirely new episode or season using that IP.
Yeah, I don't think we're far off from that at all. I would say single digit years, of course. In my mind, that's what I go to. But it's also a good segue into kind of the safety of this. That's not allowed. So what you just described is not possible for a consumer to do. So that's part of like a lot of the safety guards in this thing. So I love that idea. I think that's definitely going to be a thing. But whoever owns that IP, I think The Office is who owns The Office?
Paramount.
So Viacom. I don't know if they do. Do they? Yeah, they do. They. Either way,
it's on Peacock exclusively.
Peacock is NBC, so that'd be Universal, I think.
Yeah.
Anyways, whoever owns that IP would control that user experience. So I think that's a cool use case, but that's again a good segue into kind of some of the safety things. Is you can't create any image and likeness of an existing person and use it in these generated videos. So that's one important one. So for instance, you can't take a politician and have their speech be recreated for nefarious reasons or even funny reasons. And so, OpenAI will be super, super careful about, use cases like that and making sure that that's just not possible unless there's safety guards in place.
Yeah. And the use case I would imagine that is universal. It's putting that out. they're the ones that are licensing the model from OpenAI to use on their IP so that their customers can come in and say, okay, for $50, you can generate, a whole new season of The Office using our IP. And you can decide how you want to do that. Or here's like several other that are highly rated that other users have generated. I think that would just be so cool. And that would make IP and royalties and all of those sorts of things so valuable for those companies that own those and those actors already. I could see that just being a way that media gets disrupted in a good way. It's like you can really increase the value of your existing IP. Let's talk about one of the other safety issues going on with this, and that's just being able to purely understand like if what you're viewing on the internet is real or is fake, is generated by AI. So you throw in the notes talking about metadata being attached to these videos that are being generated. And then you also had a really good point about maybe it being a good thing in some ways that OpenAI made it here and made it as high of quality as what they have first before open source got access to it. Obviously, when open source gets a hold of it, they can kind of do what they want with it. First, if you can just kind of provide a little bit more context to the note that you put in there about the C2PA metadata being added in and why that's important. Let's talk about the concept of kind of losing some trust in what we're seeing online.
Yeah. So C2PA is a standard that exists so that generated images and video are at least to the best of the ability of the way technology works, traceable back to the creator using metadata. There's plenty of ways to get around it, so it's not perfect. It's not going to work perfectly, but there are safety guards in place to try to track where video was created and generated and whether or not it was AI or not. So there are safety guards in place to try to track that stuff. But again, the simplest way to get around that, for instance, is if it's on your phone, you can screen record a video and then repost it and the metadata is gone. So, a lot of that kind of stuff is just a technical challenge that, there are things in place, but it's not perfect. So it's, whether or not content is real or fake or where the origins are from is always, I think, going to be a problem over the next several years. And that's, leading into the open source discussion, why there's such a heated debate between, whether open source models versus proprietary models are the direction we should go. And I personally think it's both for the sake of democratization of this technology.
Let me pause you there just real quick on a point. When you say both, I think that can work, but one has to get there first. Which would you prefer that gets there first?
Well, it depends. I think in most cases, you actually want the proprietary technology with a lot of these, let's say, video generation. Again, it just is context dependent. But if we're talking about video generation, then I would want proprietary models to win out first, because you would hope that whoever is running that proprietary model is a company within a government that has, standards and has, safety guards in place throughout all of the economy for things where, there are explicit and just parental controls on what can hit, legal content distribution channels. So like, for instance, in America, OpenAI adheres to, you can't have explicit, sexual material, gore, or really just gruesome material come out into the general public. And they're adhering to those safety standards. And so in that case, it's great that a proprietary model was created and got out first, because now OpenAI can work with the government to make sure those safety guards stay in place, and that, the public is not being put in danger of, again, really sexually explicit content, really gory, inappropriate content. So in this case, I think proprietary model being there first is great. Now, in other cases, on why people have an argument for open source is now all of a sudden OpenAI has a ton of leverage and control over what is censored and what's able to be created and what's not created. And so over time, if there's not an open source community to compete with OpenAI and create models other people can access and leverage the technology with, then OpenAI just kind of has this opportunity to control what people can generate and what they can't. And nobody wants that. And so again, when I say both have to exist, I truly believe that, but it's just context dependent on which one gets there first in what situation. And I think this is a case where, you definitely don't want the open source community creating something like this prior to governments or private or public US entities, so that we can get out in front of the safety measures. Because if a nefarious person gets an open source model that can do this stuff and all of a sudden just releases it on the world in the form of social media content without anybody knowing, that's a terrorist attack. That's chaos. That can't happen. So that's where open source is not appropriate.
Yeah. And for the listeners that might not be super versed in the differences between open source and proprietary, open source is like what it sounds like. Anybody can come and use that model and develop their own uses for that model on the foundational part of it. So like when the controversy around Taylor Swift and some of these AI generated explicit photos came out on Twitter, that was because an open source model is being used to generate those. Like you can't go to OpenAI, to ChatGPT or DALL-E and be able to generate images like that. So when we say open source, it's truly the foundational part of the model that you can take and build whatever other use case you want to with that, which in a lot of ways has a lot of positives. It's very good for the ecosystem, but in some ways it obviously makes it a lot easier for nefarious actors to come and take that software and the power of that software and use it for not so great purposes.
I mean, it's just a good example of like the importance of, well-established governments and safety guards around technology and regulation. This is a classic case of why it's so important, because we're blessed that we're in America where, we have these standards and that we're first to this technology on this scale, and that China or Russia was not first and attacked, our country with content like this. And, we could do this to other countries. This is a weapon. This is one of the most powerful. This is one of the most powerful things humans have ever created. And so to have a regulatory framework and just these proprietary opportunities to advance a technology before the general public and terrorists can get their hands on this stuff, that's just what I'm saying is so important, is that in this case, I'm glad that a proprietary model was created around this by OpenAI.
Agreed. And a thought experiment that I was talking through at work with Greg when this first came out on Thursday. And I think this is something that would be possible now. So you've seen the movie The Great Hack about Cambridge Analytica and the 2016 election. Imagine supercharging the sort of Cambridge Analytica style social media content delivery, except with being able to synthetically create social media content using something like Sora. So being able to understand and have the data from social media of like, here's what inflames certain people, but being able to make the perfect video. You're not having to rely on traditional media production methods to do it. You have AI being able to generate it and being able to deliver it, and like building, like that is the equivalent of essentially building a nuclear weapon from a software perspective. Like that is the kind of power that is starting to be able to be put together. So obviously determining who gets there first and how it's regulated and how all of that is brought about is super, super important. Anything else to add to the Sora story before we move on to Nvidia?
Yeah, I would just say we just need to pay really close attention to where you're getting your media from. And as a society, we need to create really just kind of mental models and more safety guards to be more conscious of that. And, I think we oftentimes are getting caught up in this idea of, we don't trust the media, or we don't trust where our news and information is coming from. That's about to accelerate. And we really, as a country, and I think as a society, just really need to align on, what we want our rules and regulations to be around information. And if we are in this state of chaos now on what is legal and what's not, and what free speech is and what free speech isn't, we're about to go through an even bigger mess than just social media. Social media, I think, was just the precursor of what type of content people are controlling and not controlling and seeing and not seeing. But now when you can just create content and the cost of creating content is zero, these debates are going to be way more important. And if we don't align as a country on what we believe freedom is, or what we believe should be regulated and what's not regulated around this stuff quickly, that'll be a great opportunity for another country to just really take advantage of that. And we already saw it, to your point, with Cambridge Analytica. They took advantage of holes in our social media privacy, and Cambridge Analytica was a terrorist attack on our country that arguably got Donald Trump elected. And we cannot let that happen again in another form And so we've just really got to be conscious of this kind of stuff going forward and learn from our mistakes with social media.
Yep, 100%. Let's move on to discussing Nvidia. So a lot of chatter going on about Nvidia as their valuation soars. So correct me if I'm wrong here. They're now the fourth most valuable company in the world.
I know they overtook
market cap?
companies like Amazon and Google. I'm
Pretty
not sure
crazy.
where they fall. I would say, somewhere top 5.
Okay. All right. Why don't you start us off by just kind of setting the context around what NVIDIA does, just in case any of the listeners are not deep in the tech world like us and don't know about NVIDIA and how it's kind of underpinning the entire AI ecosystem right now. And then that's going to lead into all sorts of different tangents that we can go down. But let's start there.
Yeah, so NVIDIA really pioneered a hardware called GPUs, so graphics processing units. And traditionally, they were used for video games and like really heavy duty research. And they've been building these things since 1995. And so they've really been honing in this technology for, again, the other reasons other than AI. But what people started to realize was that these GPUs were really good at running very complex tasks, and running parallel processing is kind of the term around what these GPUs are really good at. And in order to have really powerful AI models and train those models and also run inference and all of these really complex algorithms, you need really powerful computers running parallel operations that are super powerful and really efficient. And it just turned out that GPUs were really good at that. And so as soon as NVIDIA realized that, they started to really focus on that niche within the tech space. And at that time, it was a really small niche. But what we've seen is that AI has grown and grown and grown. And now all of a sudden, NVIDIA has found themselves in a very, very perfect position to capitalize on this gold rush towards artificial intelligence. And so with the combination of just there being a general chip shortage and their specialization in GPUs and customizing GPUs for AI applications, they are now one of the most valuable companies, to your point, in the world. They eclipsed $1.8 trillion valuation in a matter of about 8 years from maybe $40 billion valuation. So it's a rise like we've really not seen many times throughout history. So they are a classic example of their founder, Jensen, taking just a really great long-term approach to building a company, really focusing on a niche, doing that niche really well, and then later down the road that turned into something much more, which is typically what all the great companies in the world end up doing, whether it's Amazon and books, Google and search, and Facebook, and is she hot or not? So there's plenty of examples, and Nvidia is just another one of those.
Mm-hmm. And just to help the audience kind of understand where Nvidia sits in terms of the AI supply chain. So Nvidia is getting the semiconductors from Taiwan Semiconductor Company, correct? And then they're the ones that are making the GPUs using those chips that Taiwan Semiconductor is creating. So we're going to talk about Sam Altman trying to scale up the production of the hardware side of AI. And just so we understand kind of where everything lies, it's like you've got the semiconductor production, then you've got GPU production from the materials that are created with semiconductors. And the semiconductor chips are where we're seeing the greatest shortage right now. So that's kind of where the shortage is starting when you're hearing about production issues and like OpenAI's growth being kind of capped right now because there's not enough GPUs, therefore not enough chips. That's where that's coming from. So we'll talk about that a little bit more, but I just wanted to kind of establish that as like, where does NVIDIA sit in terms of the AI value chain? They're one upstream from these semiconductor chips, the production of those from Taiwan Semiconductor Company. All right, taking it from here, you had some notes in here about like where NVIDIA is kind of positioning themselves within the AI ecosystem, comparing them to Cisco. Talk a little bit about where they could continue building into this space and what they could become as AI becomes more centralized in terms of critical software infrastructure for future businesses.
Yeah. So I think just to frame it for people to really understand what's going on here, we are rebuilding the internet right now. So we are completely rebuilding how our infrastructure as a technology works. So an example of this from an investment perspective in the US alone, Intel is investing in two chip factories, one in Ohio, one in Arizona, $20 billion and building these plants out. Samsung, $17 billion. And there's several more of these throughout the United States. And a lot of this is geopolitical. So we don't want to be reliant on Chinese and Taiwan manufacturing of chips. And so we want to bring them over to the United States. But a lot of it is also just demand is way outstripping supply. And so, there's hundreds of billions of dollars being invested in the United States right now to build these chips. And the demand is being driven by this insane investment in new infrastructure around enabling artificial intelligence. And so NVIDIA, again, is just really well positioned for that to take place. And so where NVIDIA sits is really this opportunity to create almost another AWS. And so, AWS is Amazon Web Services, and most of the websites, most of the applications you use, data is passing through AWS in some way, shape, or form. And so even prior to AWS, there was Cisco that built a lot of the internet infrastructure. And so I say all of that kind of history and all this investment just to say, we are rebuilding the internet right now, and we're rebuilding it in a way that it can leverage artificial intelligence. And so NVIDIA has just found themselves again in this perfect position. And so what I assume they're going to try to do is really become again an AWS service provider where they provide this on-demand hardware layer for businesses to build on and train models, build applications, and build kind of an ecosystem around their hardware for more of a services model, exactly like AWS or Azure or Google Cloud providing Google Cloud services. So that's, I think, what they're going to do for the AI movement, and they're in a prime position to do it. And over time, we'll just have to see how they, protect themselves from becoming a commodity, because the hardware for the internet is now a commodity. It's cheap. There's no margins to be found. And so Cisco and others that maybe were pioneers and had a massive run up in their valuation, just like Nvidia is having now, eventually fell because their margins fell because of competition, because it's a commodity. And so Nvidia has to figure out, how to prevent that from happening to themselves. They've got several years to do it, but they've got to be figuring that out right now. And I would say, if I'm reading and kind of learning as much as I am about what I'm seeing here, I would guess that they're going to start to make really big investments in really niche models and applications of artificial intelligence and help those companies grow within their ecosystem. So for instance, there might be a company building a really great proprietary healthcare model that requires insane amount of compute. NVIDIA might approach them and say, hey, we want to be the exclusive provider for you on your hardware for this. Partner with us. And that company will have to make a really tough decision to spread out their compute across a lot of different services and have redundancies, or maybe just take a really big bet on NVIDIA, co-invest with NVIDIA and get there first and build a really great application. So that might be where they kind of spread and hedge their risk. Or they create some applications that sit on top of their hardware for themselves to sell, just like Microsoft is doing with Azure. They've got Azure for compute, and then they've got this very large suite of B2B enterprise SaaS that sits on top of Azure for large enterprise organizations to build with and run their business services on. So there's a lot of directions they can go from here. They're in a really great position to kind of control their destiny, but they've got to figure out ways to not become a commodity like Cisco and others when the internet blew up.
Super interesting. I think one of the things I want to hit on and just elaborate on a little bit more and then lead this into another story is, you say we're rebuilding the internet right now for AI, and just to reinforce why that is. So why can we not just run these AI models on something like AWS? And this is a question I'm asking you because I'm not 100% certain. The reason we can't just go and run these AI models on AWS is because the servers that AWS is providing are not built in a way that is supposed to support these LLMs and these AI models running on them. And therefore, that's why the NVIDIA is in a good spot, is because they're producing the hardware that is going to be needed to create essentially these new server warehouses that are going to power, AI, being able to host and run these large language models on top of them. And so the reason I wanted to bring that up in context of we're rebuilding the internet right now for AI that is a physical rebuilding of the internet. Obviously very expensive. Evan mentioned billions and billions and billions, hundreds of billions of dollars being poured into this right now. One of the other stories I wanted to discuss alongside this Nvidia valuation is the absurd headline that came out, I guess it was a week or two ago, about Sam Altman asking for, or saying he was going to raise between 5 to 7 trillion to try and scale up the semiconductor production and the physical infrastructure side of artificial intelligence. Evan, tell us what your initial reaction to that was and why you think the numbers that were put to that were put to that.
I think it was more of a PR move than it was actual grounding in reality. And I do think Sam Altman knows something nobody else knows, which is, how much compute are we going to need for the applications that are possible to be built with AI within a certain time frame? Because he arguably has the best data point of anybody of how much compute is needed to run ChatGPT, for example, at a massive scale. They had scale issues. They had to stop people from accessing ChatGPT because there was so much demand on their servers to run ChatGPT because there were so many people subscribing and using the app. So I would say that he probably has some amount of data that informed that number, and he might have 10x'd it and said, this is the amount of investment we need over the X number of years as a PR play, but to just get in everybody's head. Again, we are rebuilding the internet, and that's just not an easy feat. We have to rebuild the entire stack. And I think that he's, just kind of really being aggressive and getting us to wrap our heads around what's going on right now. And I don't really think that society or just the average person right now is really understanding, or maybe even has a really strong incentive to understand right now, because it's such an early stage emergent technology, and he's just getting out in front of that. I would say in 2-3 years, everybody will truly understand what's going on here when they start to see more AI applications affecting their everyday life.
Yeah. I put this on my story when the news about him trying to raise between 5 and 7 trillion came out. There are a few people that are planning as heavily for the future as Sam Altman is for artificial intelligence. And I say that for a couple of reasons. So I think Sam is identifying the two biggest bottlenecks for the full application of AI across, everything, where the scale we're trying to get it to in the future. The two bottlenecks he sees are energy and compute power. So he's trying to draw attention to the compute side of this and the hardware side of this by talking about needing between $5 and $7 trillion to get it where it needs to be. The other part that I thought was really cool is he also invested, I think, around $375 million, somewhere around there, into a fusion startup called Helion. Helion is making a lot of good progress in terms of commercializing fusion energy. He sits on, I think he's the chairman of the board on Helion as well. And then, as you know, OpenAI got that huge investment from Microsoft. And then Microsoft turns around and does a power purchase deal with Helion, saying that by 2030, they're going to be purchasing some of Helion's energy produced through fusion to power their data centers. So I just think it's super interesting that Sam is kind of playing a few steps ahead and saying, okay, we want to get AI scaled up to this point. What's going to prevent us from doing that? Okay, it's likely going to be the sustainable, clean production of energy. Therefore, I'll invest in, pay attention to what's going on in fusion. I'm sure he's got other bets placed elsewhere. And then, of course, how can we scale up production, which is honestly might be a heavier lift than the energy side of this in terms of the physical infrastructure. They're probably pretty comparative. Two of the biggest problems that you could possibly go after right now to solve. He's positioning himself right in the middle of it, which is honestly just fun to watch.
Yeah, I would also just, I agree. Sam Altman is, one of the greatest minds of our generation and very powerful position. But I do also want to bring attention to the role Microsoft is playing in all of this.
100%.
None of this would be possible without Microsoft. And so what you just described there was, Microsoft seeded OpenAI. Really what's going on here is Microsoft is fully backing Sam Altman, and Sam Altman is a co-CEO of Microsoft. And what they're saying is, hey, Sam Altman, you're looking way farther than we are because we're a big, huge enterprise. We can't move as fast as you. we really like what you're doing and you see the future and you want to build it. Here's your seed investment for OpenAI. Here's $10 billion. Oh,
Yep.
OpenAI needs hardware. Let's just go ahead and do a co-ownership. We own 51%. Here's all of the hardware needs you have. Oh, now you need energy and you think that nuclear is the way to do it. We'll pre-purchase your nuclear energy so that you can go get the investment dollars from others, knowing that there's a pilot program on the other side of this. So what they're doing is they're just kind of backing Sam Altman's vision. And if he's not going to be the CEO, or if he's not already acting as kind of the visionary CEO of Microsoft behind the scenes, then one day he will be the CEO. Potentially, I think Satya is one of the greatest CEOs of ever, just frankly. But his successor is without a question going to be Sam Altman if he stays within this Microsoft ecosystem. And it'd be hard for him to leave because there would be no Sam Altman without Microsoft, at least in this place that he is now today in his career. So I think that that's kind of the story here, is really this symbiotic relationship between Sam Altman and Microsoft.
Yeah, I think that's a great point to call out there. The way our friend Nico put it, he said Sam Altman is just Microsoft's R&D department.
Yeah,
which I thought was great too. It's the same point you're making there. Anything else to add to this NVIDIA side of the story, talking about the physical infrastructure side of artificial intelligence before we move on to talking about Google's new Gemini 1.5?
Nope.
All right, let's dive into this story, which is again one that might be a little bit more in the weeds. We're going to be talking about what's called a context windows. Google has released Gemini 1.5, which is their large language model. And what is significant about this is the size of the context window. It's got a 1 million token context window. Evan, tell us what the context window is, what a token is, why that's important, and let's dive into this story.
So when you interact with a large language model, kind of the currency in a way, the transactions being done with what are called tokens, which is a portion of a word, a sentence, or maybe multiple sentences or multiple words. It just depends on kind of how you structure it. But really, to have a 1 million context window of tokens is really about how much content you can put in the prompt that goes into the large language model as the input that then creates the output. So 1 million token context window is really kind of a breakthrough, at least right now, because the closest thing released prior to this was maybe 128,000 tokens or something like that. I think was the largest that I saw. And this is multiples larger. And so really what this means is you can put, full books, you can put really long form video like movies into it. You can put entire podcasts. You can put all of this now long form content and let the model have that in a prompt to then let the large language model, run processes and inference on. So that seems to be one of the largest breakthroughs with this new model from Google. So we'll see what kind of applications are built using that. It'll be really interesting, I think, to see how this affects, again, media, given you can put a whole media movie into it, or long form podcasts and transcripts from, books, 700,000 words and things of that nature can now be put into these context windows, which, new applications will be built on that alone.
Yeah. And the discussion here is really going to start centering around providing large language models with enough context, with enough detail, with enough data to be super useful. And so this is where we'll get into talking about RAG, retrieval augmented generation as well, which is kind of like, maybe you could call it the alternate of having a super large context window, as we're talking about here. What the goal of all of this is trying to pull in enough data, whether it's about a company and a particular project they're working on, or you're trying to take a book like what you're talking about and create sequels based off that, whatever it is. You're trying to get enough context and enough data within this large language model to where you can do all of these secondary functions and workflows from it. So talk about what retrieval augmented generation, the role that plays in this, and kind of the difference between the two right now. This is again a really in the weeds sort of topic, but this is probably I'd say you would call it one of the more cutting edge sort of things that are going on in the space right now is talking about this RAG problem, or not problem, but RAG way of getting more data into the model.
Yeah, so whenever, I'll just use real world examples. Whenever you're using ChatGPT and you're just chatting with ChatGPT, you're interacting, unless you're using a plugin or a GPT or other data inputs. If you're just interacting with just straight up Chat GPT using GPT-4, you're interacting with what is called their foundation model, which is their foundation model is just trained on the internet's text and other proprietary information, and it's just kind of you get what you get out what you put in, and really it's you're only interacting with that particular model. However, if you're using large language models or AI within the context of a business, you want to leverage maybe real-time information, or you want to leverage facts about your business or knowledge about your business and your products or your customers, and you want that data to be interactive with these large language models. You have to use this framework called retrieval augmented generation, or RAG. So it's a matter of, how do I get my proprietary business information into the prompt to then put into the large language model? And there's a step in between what you put in and that information being put into the large language model, and that is retrieving information from a database or somewhere in your organization. So that's what RAG is again, just retrieving information to put into a prompt for the large language model to run inference on. So in order to build kind of a complex application, or build kind of a workflow that's useful in a business context that is retrieving relevant information, you've really got to build a brand new type of architecture to leverage that framework of RAG, so that you're not just interacting with the foundation model, you're interacting with real world data. So that's what that is. And so I'm developing an application that is heavily reliant in building advances in RAG technology. And so that's, whenever you see companies refer to RAG, that's what that is.
And when you talk about a different architecture, that's when you're referring to what's called a vector database, correct?
Yeah, that's the most prevalent kind of part of that tech stack is a vector database. And then there are all kinds of model architectures. There's one that actually Gemini was built on, called a mixture of experts, that is a really great framework for retrieving relevant information and kind of routing based on the input to the best data possible. And so there's all of these different frameworks and kind of ways to retrieve the most accurate information. And so I guess to take it a little bit further, while there is a 1 million token context length, some people were questioning how that affects RAG or other methods of leveraging large language models. But the reason RAG is important is because you want the prompt that you put into the large language model to be as accurate, relevant, and timely as possible. And if you just dump a ton of data into the context window of one of these large language models, there's likely going to be information in there that's not relevant, or is just not timely, because maybe you say, oh, I just want to put my entire file system and all of our files and all the text in those in the context window and see what the large language model does. That's just not how these really work. And you want it to be producing outputs that are not hallucinations and are accurate. And again, just in order to do that, it's got to be retrieval augmented generation.
Maybe this is a good time to transition to talking about devise. Just in terms of, you're a founder building in the AI space. On the first episode of the season, you talked about there really is no better way to learn than by building a company. You've been learning a whole lot here lately, and it's been fun to kind of learn alongside you and have some of these discussions around what sounds like it's kind of the cutting edge of where the AI space is right now, talking about things like data structure and how you're building kind of the back end infrastructure to allow AI to be integrated into businesses. So let's just talk about, what you're paying attention to, what you're learning right now, where you think the space is kind of headed from here now that you've been building for a few months. I know you're still obviously very early in all of this, but I can recognize that you're learning at an incredibly fast pace. So yeah, take that wherever you want. But where does your mind go when you think of, what are you paying attention to in the space?
Yeah. Well, when I set out to build an AI company, I really wanted to solve the first most important problem in my eyes was kind of this opportunity to build a collaboration app that is an AI application. And I think as I've been building it, I'm learning that in order to be an AI application, you have to have kind of this new architecture that you build on to actually have the application be influenced by artificial intelligence rather than there just be AI features like summarize my Slack channel or generate a summary of this podcast. Those are AI features. And if that lives within an app, that app is not an AI app. And so what I'm learning is that the architecture that you build your application on needs to be built so that these large language models, and to take it even further, without getting too much in the weeds, is just these agents to navigate the data that you're building your application on to generate the user experience. And so that's what we're doing with our application. Our application is a project management platform that right now we're targeting marketers and account-based salespeople with so that they can complete projects really quickly on our AI application. And so an example of that would be everybody's familiar with using maybe Asana or Notion or ClickUp for their project management. And what we're doing is very different than what they're doing. And in their apps, you're really kind of recording the work that you're doing and tracking the work so you can prioritize it and track progress as a team. That's really the extent of what those applications do, is they're glorified like task management apps. But what we've done is create a collaborative environment where a team can interact with AI, but let the AI actually guide the user experience of the project using their own company data and using context of the project. And so the difference would be in Asana, you kick off a project and somebody has to configure either with templates or with their own mind, what are the relevant documents, what are the relevant tasks, let me delegate these tasks, let me invite the right people, and let me write out what the next steps are. In our application, somebody creates a project, the AI intercepts that project, understands intuitively what the team's trying to do, and then the AI creates a workflow for the team to make the best decisions on how to strategize and plan, how do we do this project? What are the tasks that we actually really need to prioritize and create? Maybe there are risks and bias that we're not thinking of in this project that a human no longer has to monitor. And so we're letting the AI actually generate the user experience and push the project forward at a pace that I've been using this for our own business. I've never seen an application really assist in work the way that we've kind of designed this to work. And so it's kind of really exciting and a new way to think about, I think a lot of apps are describing themselves as AI apps. And you cannot be an AI app, in my opinion, if the AI is not determining what the user experience is and actually determining how the app is constructing the user interface. And what I mean by that is, again, in Asana, there are templates. And when you use the application, a human is determining what the user interface is and what the pages are. But in an AI app, the AI is doing that for the user based on what they're trying to achieve. And another concrete example of this is, let's say, Salesforce. If you are wanting to change a record of a customer in Salesforce, you are navigating multiple pages, and maybe that record determines a new email being sent. And so right now, in the way the Salesforce works, a human has to go search for a contact, go to that contact, change the record information on that contact, and then go open up an email app and type in an email they want to send to that customer based on what they just changed in the CRM. And so they're interacting with all those user experiences. They're having to determine what pages they open and what they don't. In an app like what we're building that I consider to be a real AI app, the user just says what they're trying to do, and the AI brings them those pages automatically without them needing to navigate it. And the AI might actually do that work for them. That is the difference between, I think, the old architectures that businesses are built on and what we're building. And in order for that to be a really generative user experience and workflow, it requires a brand new architecture, brand new data architecture. It's not just relational databases anymore. It's a brand new type of database called a vector database and many other pieces of the puzzle that enable a large language model to consume data, run inference, and then kick off other actions on the back end for users to get a lot of value out of. So I know that was a lot, but that's kind of what I'm learning. What we're building is really this opportunity for AI to actually determine the user experience and complete projects faster for a team.
Yeah. And where my mind goes when I hear that, and what it seems to come back to for me, is one of the more relevant topics in AI right now is data structure, because that determines how a business can integrate AI into their business. And so for any business owners that might be listening, like, do you think that smaller, more nimble businesses have an advantage as opposed to like super large businesses that have their data very structured and it'd be very hard to change? Like, how do you think about the advantages between, some of these behemoths? Like, are some of those behemoth companies that are very set in their ways in danger of being disrupted a little bit now that AI, they can't necessarily adapt very quickly to this new data structure that needs to happen on the back end? How do you think of that?
I think there's a big difference between, so there's very large software companies that have very structured architectures, but then there's other companies that maybe are not necessarily software companies that just have proprietary data that they own. So the companies that have proprietary data that they own that might not be software companies are in a really, really fantastic position right now, because they can use that proprietary data to train models that they own the models. But what I think is the opportunity to disrupt industries is those software providers that have built project management software, CRMs, whatever it might be, ERP systems. There is now a great opportunity to attack those businesses with true AI applications that are built on different architectures, mainly these vector databases that, again, it's this opportunity to feed a large language model the right information at the right time to run inference. And relational databases and a lot of these other data architectures are just not as good at that as vector databases. And so if you are a business that has a very large amount of text that you want to leverage within a large language model, you're going to want to vectorize that text and put it in a vector database. And so that's just one simple example of how to use a vector database, is taking large amounts of text, vectorizing it so that a large language model can go search that information and then pull what's relevant into the prompt at the right time within the right context for the team to leverage. And that just, again, requires a brand new type of software and infrastructure.
That's exciting. Well, you're definitely at the cutting edge of it, which I think is awesome. It's fun to follow along with as well. Let's kind of talk bigger picture about the entire artificial intelligence space and what's being built here. Where my mind goes is I see all these different things being developed in different ways. I feel like what we're viewing, what I'm seeing right now is we're seeing different blocks be developed. If you think of like we're stacking all of these different blocks and what are we trying to build, I think ultimately you would make the argument that we're trying to build artificial general intelligence. But I feel like what we're seeing right now is each little building block being built, seeing things like a text to video model being built and that being perfected in a way, and seeing the data infrastructure be in a way that allows for artificial intelligence to really interact with data in a way that makes sense. I see all of this kind of stuff being built in like such an incredibly fast speed right now that it really does seem like we're making progress to what I would view as getting towards artificial general intelligence. Because what artificial and general intelligence is to me is that it's just going to be the culmination of all of those things. It's going to be when we get all of those different pieces and they can all interact with each other. We have agents that can do different things, and then they're acting as kind of one entity. And I just think like it's making me realize how big of a deal it'll be when artificial general intelligence hits, like what it will truly be capable of doing. It's almost hard to put into words, but it's kind of just like you start to develop this understanding, like this awe of holy shit, like it can already do all of these things right now. What happens when you start connecting all of them and allowing everything to kind of connect with each other and communicate with each other, and to where it kind of functions as this one being? And I think that's just kind of like where my mind goes when I'm thinking of AI these days, is like it's just accelerating towards that right now. I don't know if you have any thoughts on that or your own thoughts around the bigger picture of where AI is going at this moment, but that's mine.
Yeah. Well, I just think it's, again, the kind of the comparison is the internet. In the early days, there were very, very kind of specific applications of the internet. It was just a lot of pieces being pulled together. And now the internet kind of feels like this cohesive application, this cohesive kind of environment that all connects because it's so well built out and mature. And so we're just in the super early stages of that with AI, but AI is moving, 10 times faster than the internet did. So it's just a matter of pacing, I think, is different and difficult for people to wrap their heads around. And to the question you asked earlier, do you want to be, a large organization with, bureaucracy and a lot of kind of set ways of doing things? Or do you want to be a more nimble organization? And, right now, if you're a business leader or somebody building a product, you want to stay as nimble as possible because so many things are changing quickly, whether it's architecture, data, regulations. You just want to be nimble. And so the best example of this I just tweeted about earlier is, I think everybody was confused about why Elon bought Twitter. And I think he saw an opportunity to cut down on the bureaucracy within a very large business and build a brand new application. So I think that is what's going on right now is, you want to be that nimble, small organization and take advantage of all of this pace and be able to move faster than your competitors. That's where my head goes.
Yep, for sure. Well, that should be a good place to wrap it up here. Before we end this one, this will be coming out, I believe, on the 26th, which is a few days before our event that we're putting on, the Startup Open Mic Night. So just wanted to give a quick plug for that. If you're listening to this, you're interested in technology, you're interested in startups, and particularly Lexington's startup community, would love to extend an invite to you to come to our Startup Open Mic Night, which is on February 29th. That is a Thursday from 6 to 8 p.m. There'll be free food, free drinks. If you've ever been to an open mic night for comedy, it's going to be a very similar format to that. So if you have any questions around technology, around startups, startup ecosystem, and you would like to bring those up for discussion, you'll be able to come to that event, get a mic in your hand, and chat with others that are in the space about it that also care about those same things. So this is a new event format for us. We're just kind of experimenting with ways to bring value to the ecosystem with events. Shout out to Evan. This was Evan's idea that he came up with and thought we should try. So if it flops, it's his fault. But if it's successful, it's probably TJ's fault. So that being said, we hope everyone has a great week. Please feel free to come and join us at the Open Mic Night. You can find the link in the bio to get your tickets for that. It is a free event. Outside of that, thanks for listening. We'll talk to you next week.